You're welcome. You're welcome to our class today. We are so happy to have you online. Wherever you are watching from, you can share. If you're a new subscriber, you can subscribe. If you are new to this system, you need to like, share, subscribe. For our returning subscribers, thank you for subscribing. Thank you so much for joining us for today's class. Today we are having chemistry. Chemistry is one of the basics in science. So today we are going to talk about chemical combinations. So first thing first, before we start this chemical combination, we need to understand the concept of combination. Combination is the basic for every chemical bonding. If there is no combination, there is no bonding in chemistry. If there is no combination, there is no mixture, there is no compound. Alright, let us go straight to understanding the first 20 elements, because it is the elements that combine. It is not a substance. It is an element that can combine. The substance cannot combine chemically. Alright, the elements we need to know are the first 20 elements. The first 20 elements. Why we need to know these first 20 is because they are the constant elements that we use in day-to-day chemistry. They appear in everyday chemistry. So we need to know them. They are hydrogen, we have helium, we have lithium, we have beryllium, we have boron, we have carbon, we have oxygen, we have fluorine, we have neon, we have sodium, we have magnesium, we have aluminium, we have silicon, we have phosphorus, we have sulfur, we have chlorine, we have argon, we have potassium, and we have calcium. These are the first 20 elements. These 20 elements are very important in bonding. These 20 elements are very important in chemical combination. Without knowing these elements, you will not know the fundamentals of chemical bonding. Let us go further with understanding the electronic configuration of all these elements. Now, the electronic configuration is the basic for any chemical bonding. It's the basics for every chemical bonding, because it will tell you how the electrons bond with each element, how the electrons come together to form a compound, because it is the electrons that comes together, that moves. So if we don't understand the electronic configuration of these elements, we cannot move further. Now, what do I mean? Now, we have what we call the shell in an element. All these elements have shells, because the shell is where the electron is found. Now, every atom has three particles, which you have proton, you have neutron, and this is the electron. Now, the proton and neutron are found in the nucleus of the shell, while the electron revolve at the outermost shell. Alright, now the electron is negatively charged, proton is positively charged, while the neutron is neutral. Now, due to the electron is positively charged, the combination that happens, the bonding that happens in every element or in every chemical combination is done by the electron. So what I want you to understand is the electron movement matters. Now we need to know the electronic configuration of all these elements, knowing how many electrons that are found in their outermost shell. Okay, we have 1 to 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, and 20. So we have from 1 to 20 elements. Now we need to know that the numbering is also the atomic number. The atomic number is the number of electrons present in the atom shell. Now that means that if carbon is 6, carbon has 6 electrons found in the atom shell. That means 1, 2, 3, 4, 5, 6. Now this is for carbon. For oxygen, oxygen has 8. Have 2. Always, in fact, in all elements, we have the first shell as a duplet. It has 2 electrons in its shell. In the first shell, the first shell is called the K shell. Now the first shell has 2 elements, while the other shells have 8 elements, 8 electrons rather, present in the atom shell. Wow! Now that 8 electrons makes it an octet shell, while the 2 electron shell is a duplet shell. Just note that. Alright, let's proceed. We have oxygen having 8 electrons. That means 1, 2, 3, 4, 5, 6, 7, 8. Now it is now left with 2 electrons to make it an octet shell. Alright, now with this element, with this element electronic configuration, we will say that oxygen has 2 minus. That means it needs 2 electrons to complete its shell to be 8, to make the shell an octet shell. Alright, now if it needs 2 to complete it, that means it's going to take 2 from the one that has 2 to give. What do I mean? Let us look for an element that has 2 to give. We have magnesium. Alright, magnesium comes like this. 1, 2. Magnesium is number 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now magnesium has 2 to give. Magnesium has 2 to give. Now when oxygen reacts with magnesium, magnesium will take the 2. We carry the 2 and give to oxygen to make it an octet shell, to fill the shell, whereby we have 2 and 8. We have here 2 and 8. If you are with me, you understand that it has successfully given 2 elements to oxygen to complete its shell, whereby it is left with 2 before. Now it has given. Now this character of giving is always performed by metals. Metals have this capacity of giving electrons. We have metal that have 1 electron in the atom shell, it will give it out. Any metal that has 2, it will give it. Even though it has 3, it will give it out. That's the nature of metals. They have the capacity to give out electrons, while non-metals has that capacity of receiving electrons. They have incomplete octet shell. So what happens is the metal will give them electron and they accept. They have the accepting capability, while the metals have the giving capability. Alright, let's move to the next point, types of chemical bonding. This is where we will note the types of chemical bonding.